Hi guys, and welcome to the video for surface area of rectangular prisms. So in this video, guys, we're going to be able to find the surface area of a rectangular prism. We're learning this because we use surface area when we talk about painting our houses or covering a three-dimensional object in like wrapping paper. You'll know you're successful when you can analyze the dimensions of a prism and then find its surface area. So let's first talk about what is a prism. A prism is a solid three-dimensional object with two identical ends called bases. So, in a rectangular prism, it doesn't really matter what side you call bases. And then it has three flat sides called lateral faces. It doesn't really matter what you call bases and lateral faces here. If you decide that this is the base right here, then it has an opposite base over here. If you decide that this is the base, then you have a base down here as well. Generally speaking, we like to say that the base is the area of the shape that the surface is sitting on. So we would use the one down here as a base, and then the one on top would also be a base. The shape of the ends, so the shape of the base, gives the prism its name, such as a rectangular prism shown here. There's prisms of all types, such as triangular prisms. You can have square prisms, pentagonal prisms, whatever shape is used to construct the bottom of the prism will give it its name. So let's talk about what surface area is. Surface area is the sum of all areas of every face called surfaces that enclose a solid shape. So for a prism, that includes the bases and the lateral faces. Surface area is calculated in units squared, just like regular area. So you can see the square prism, rectangular, it's technically a rectangular prism here. But in order to calculate, or the surface area would include all three faces that we can see, and then the three faces that we cannot see as well. So in order to calculate it, we need to remember, so I have this diagram has dashed lines to represent the sides of the figure that we cannot see. Rectangular prisms have 6 different faces, so we need to find the area of all of those. To find the area of a face, we determine the type of shape that face is. In most cases for a rectangular prism, the shape will be a rectangle, and we will determine the type of then use that to calculate, the appropriate formula for finding its area. So since all the shapes are rectangles, we will use area equals base times height, or we'll use area equals length times width for each one. You can also use the formula area equals width times height as well. In any case, you're basically doing area of a rectangle, which we know to be base times height. Each face has a duplicate face across from it in a rectangular prism. So this face on the top here has this face on the bottom, and then you have the faces on the sides, and then you would have, it's going to be tough to draw, this face on the back, and then you would have this face up front. So you have top, bottom, side, then you have the lateral face in the back and the lateral face in the front. So that cuts our workload in half. We only need to find the area of the 3 sides, and then we can immediately know the area of its opposite side. So when I calculate the area of the top, I know the area of the bottom base. When I calculate the area of one of the small sides, I know the area of the other small side. When I calculate the area of the front lateral face, then I know the area of the back lateral face. So the formula for a rectangular prism is essentially the surface area is essentially 2 times length. I need my eraser here. So 2 times, use parentheses, length times width plus width times height plus height times length. Plus length times height. So what you can do is calculate all of those, length times width. You would calculate width times height, and then you would calculate length times height, and then you're going to take that you're going to sum all three of those together and multiply it by 2. The other way that you can do it is you can simply just calculate the value for all 6 sides, and then 3 of the sides, multiply it by 2. Or you calculate all 6 sides and add it together. So let's just get started on some examples. Find the surface area of the rectangular prism. So I'm going to use the formula. Surface area is equal to 2 times the length times width plus the width times height plus the length times height. So we're going to call 45 the length, we're going to call 15 the height, and 25 centimeters would be the width. So we have the width going this way, we have the height going up and down, and the length going side to side. So just in case you missed that, I'm going to just kind of repeat that and rewrite it. So length goes side to side, height goes up and down, and width generally is diagonal side to side. So you can see the W is like diagonal side to side, the height is up and down, and the length goes completely straight side to side. So then what we can do is take the surface area, or write surface area, SA, is equal to 2, and then we're going to substitute some values in here. The length times width, so length times width, 45 times 25. 45 is the length, 25 is the width, plus, okay, now the width is 25, and the height is 15, so 25 times 15, plus, and then length times height, 45 times 15. Okay, so it's important to remember our order of operations here. We're going to do the parentheses first, and within the parentheses, we're going to do all of the multiplication, and then we are going to do the addition. So we're going to go ahead and say surface area is equal to 2 times, and now we're going to go ahead and go do it. 45 times 25 is 1,125 for the first part, plus, so then 25 times 15 is 375, plus 45 times 15, which is 675. So then we're going to add those expressions together. So 1,125 plus 375 plus 675 is 2,175. So that's what goes on the inside of the parentheses, and it's going to get multiplied by 2, and that would be the surface area. So in total, so in final, when I multiply that amount by 2, the surface area is 4,350, and then we have centimeters here, so it would be centimeters squared. So the surface area of this rectangular prism is 4,350 centimeters squared. Okay, so now I reduced the numbers, but the idea is still the same. Find the surface area of the rectangular prism. So 11 is going to be the length, 5 is going to be the width, and 6 is going to be the height. So the surface area is equal to 2 times the length times width, plus the width times height, plus the length times height. So then we're going to go ahead and SA is equal to, we're going to fill in all of the measurements here, 2 times. The length is 11, so 11 times the width of 5, plus width times height, so 5 times 6, plus length times height, 11 times 6. Okay, so then we're going to multiply it out. We get the surface area is equal to 2 times 55 plus 30 plus 66 So 55 plus 30 plus 66 is 151. So the surface area would be double that amount. And then, so 2 times 151 is 302. So the surface area here is equal to 302. And again, the unit is centimeters, so it would be 302 centimeters squared. So the surface area of a right rectangular prism is 358 square centimeters. Its length is 12 and its height is 5. Find the width of the prism. Okay, so we have a length of 12 centimeters. We have a height of 5 centimeters, and we are looking for W, the width. So what we are going to do is use that formula, but we're going to use it backwards. So the surface area is equal to 2 times the length times width plus the width times height plus the length times height. So we have 2 different W's in here. We're going to substitute all of the values that we know. So the surface area is equal to 2 times, and then it would be, we know the surface area. The surface area here is 358. So we're actually going to substitute that in. It's equal to 2 times the length of 12, W, since we don't know the value of the width. The height is 5, so it would be 5W, plus the length times the height. So 12 times 5. So what we will get is that 358 is equal to 2 times 17W plus, and then 12 times 5 is 60. So now I have a completely solvable expression. These are the two that combine to 17W. So we will use the distributive property. So 358 is equal to, so we're going to distribute 2 to both, 34W plus 120. So then I'm going to subtract I'm going to take 358 and subtract 120 from both sides of the equation. So minus 120 here and minus 120 here. So we get 238 is equal to 34W. So then 238 divided by 34 gives us a width of 7. Okay, so it doesn't actually look like it's to scale. Like this doesn't look like 7 because it looks greater than the length, but that's okay. It doesn't really matter. We solved properly for the width of 7 here. And so then now we're going to do an application problem. Mike wants to paint his room, but he doesn't want to paint the floor and the ceiling. His room is rectangular, and he measured one wall to be 10 feet and another to be 12 feet. His room has a ceiling that is 9 feet high. Each pint of paint that he buys will cover 100 feet squared and cost $6.50. How much money will he need to spend to paint his room? Okay, so when we talk about things like painting and covering walls and such, this is a complete example of an application of surface area. So they do say, and I'm going to actually use my line tool because I am not good at drawing rectangles freehand. So he's got a 10-foot wall. He has a 12-foot wall, and he has a ceiling that is 9 feet high. So I went up into my paragraph here. So I'm going to switch back to my line shape here. So to complete the figure, he would go up like this, 9 feet. And he would go up like this, 9 feet. And then you have this and this to complete the figure. And then we would have a similar shape going this way. We'd have these up in here. So it's not perfect, but you get the idea. We're then going to have, I'm going to switch to dotted lines. The easiest way is just going to be to do this. He has it dotted going this way, and this way. Indicating that those are like behind, so we can't really see them, but they are there. Now what I'm going to note is that the bottom wall or this one would be 10 feet. This one was 12 feet, and his room was 9 feet high. We do not need to calculate the surface area of the top or the bottom because it says he is not going to paint his floor and ceiling. So we need to calculate the surface area of the walls. So to calculate the surface area of the walls, what we're going to do is we're going to use the 9-foot height, and we're going to use the length, and then we're going to use the 9-foot height and the width. So remember that the surface area is equal to, excuse me, I started writing something else too early, 2 times length times width plus, then it would be width times height, and then length times height. So we are going to exclude anything that doesn't include the height in it because Mike is not going to paint any of the flat surfaces. He's only painting the the horizontal surfaces. He's painting the vertical surfaces. So in order to be a vertical surface, you need to have height. So we are going to exclude this version, or this part here. Exclude because length times width is not a vertical face. And it needs to be a vertical face in order to be involved in painting a wall. So the surface area that we have to cover here is actually going to be 2 times WH plus LH. So what we're going to do is plug in WH, so the width is 12 times 9 plus, and the length times the height, 10 times 9. So that's the surface area that we're going to use for this particular problem because it specifies that we're not painting the floor or ceiling. So the surface area that he has to cover would be 2 times and then 12 times 9 is going to be 108 plus 90. So then the surface area would be double 198. So the surface area that Mike needs to cover is 396 feet squared. Okay, so we answered the first half of the problem. Now we have to do the application part. Each pint that he buys will cover 100 feet. So in order to find the total paint used, so in order to find number of pints to buy, divide by 100. We're going to divide by 100 because it's 100 per can. So what we get is that's equal to, so we're going to divide by 100. That's going to give us 3.96 cans. But you can't buy part of a can. You either have to buy 3 cans or you either have to buy 4 cans. So in this case, anything over 3 is going to make us need an entire new can. If it's 3.01, okay, well, we still have to buy another can in order to do that 0.01. So in this case, we're going to round it up to 4 cans. And then we're going to multiply that times $6.50 per can. So then the $4 or 4 cans times $6.50 is going to cost $26. So he's going to need to buy $26 worth of paint, 4 cans, in order to cover the walls of his room. So that's it for this video, guys. Today we learned what a prism is and what surface area is, and then how bases and lateral faces are defined. We learned how to calculate the surface area specifically for a rectangular prism. We learned to take the surface area for a rectangular prism and work backwards to find a missing side. And we solved an application of surface area problem. So that's it for today's video, guys. Thanks for watching, and I'll see you in the next one. Bye-bye.